Good morning, friends. This is Durga again from ITversity. We'll be continuing on Spark and Scala workshop. Let me set up WebEx and then we will go ahead and start. Yeah, I'm sharing my screen on WebEx and then we will start, okay? Now you should be able to see my screen and also I'm starting the recorder. I hope all the folks on WebEx can see my screen and also can hear me. If you have any issues, let me know. Hello, can you guys see my screen? And can you guys hear me? Whoever is on WebEx. Okay, thank you. So as I have mentioned to you earlier, I will be taking today's class on my Windows laptop. I lost touch with Windows, but my Mac is giving some issues. It is not getting started, charged. Hence, for today's session and until my Mac issue is resolved, I will be doing it on my Windows laptop. Okay, so as part of Scala and Spark Workshop, so far we have written a word count program, and I have given you exercise to complete the entire flow, starting from. Let me open the exercise real quick. Then, if you have any questions, I will give some time to sort out those questions, and then we will proceed with the session. So we are talking about exercise 3 and exercise 4. I hope you guys have finished the entire exercise. If you stuck anywhere, let me know. I will either, if it is a minor issue, I will try to resolve it immediately. Otherwise, I will take it offline. Okay, if you don't have any issues, we will proceed further. Today we will be starting on other transformations such as joins, aggregation, etc. And then we will actually go through a program. Okay, it seems you folks do not have any questions. So let me start with the data flow diagram. Data model diagram, using which we will be exploring other transformations such as joins, aggregations, etc. I am using a data model provided by Cloudera. You have been seeing these 6 tables. So now I am actually connecting to the lab. I'm struggling a little bit, okay? Just bear with me. Okay, so it's been 6-7 years since I use Windows extensively. I'm connecting to the lab. I'm using Cygwin. I don't use Putty. Okay, let me take this again. Yeah, now I'm in the lab. Okay, so we have been connecting to this MySQL database using called retail_db using user retail_dba. If you are following my scoop content, you might have connected so many times so far. If you are not part of the scoop workshop or the other workshop which I'm taking care after this first half, then make sure once you go to the GW01, make sure you connect to the database called retail_db running on a host called nn01itversity.com. Okay, it's a remote host to this machine where we are connecting to. So we have to give the host name also and -p for the password. For retail_dba, the password is ITversity. Okay, so you can use this from gateway node or even from your machine, as long as you have MySQL client, only then it will work. On gateway node, I have MySQL client. That's why I'm able to connect to MySQL installation using this MySQL command. Once you are in the database, you are connected as retail underscore DBA. You can run show databases command. And there are 3 databases for which this retail underscore DBA have access to. Forget about information underscore schema. It is also a database, but it is a system database. We don't need to worry about it. There are 3 other databases. These are primarily for scoop. The main database which we are interested is retail underscore DB. So to connect to the retail underscore DB database, you just have to say retail, use retail underscore DB, and it will connect to the database. And then if you run show tables, you can see there are 6 tables. And these 6 tables actually represent a retail application or retail e-commerce application. Okay. So now I will be showing the data model for this. As part of Scala and Spark Workshop, we are not actually connecting to this MySQL database, but what we are trying to do is under our data our local file system under /data, there is a directory called okay, there is no directory here. It's actually under HDFS. There is a directory called /public/retail underscore DB. And you can see there are 6 directories with the table name in each of them. So what I have done is I have pulled the data, delimited, each record is delimited by comma, and then I have actually stored into HDFS. So if I run Hadoop FS -cat on the department's data set, paste, and then first let us run ls command to see the file names, and then we will use cat command to preview the data. Okay, so this is the file name. So now I can say you can see there are 6 records. Each record is having 2 fields, and those 2 fields are actually delimited by comma. Okay, so we have data in the database, and also for the same data set, for same tables, I have a backup under public retail underscore DB so that we can play with it directly. Okay, and then now I'm actually going to the data model for these 6 tables so that you understand what we are trying to do as part of future tasks. Okay, so here what I'm trying to do is I'm going to Google, and you can search for Cloudera exercise 1. Also, I have this data model in my blog also. So even if they delete, I have a backup for it to explain in future. So in this link, okay, so here it is. This is the data model diagram. So if you are familiar with, if you are from computers background, you should be familiar with this. Okay, so immediately after seeing these lines, you should be able to know the relationship between the each of these 2 tables. Okay, so total there are 6 tables. Out of these 6, first of all, we need to categorize what are fact tables, or what are transactional tables, and what are master data tables. Okay, so if you go through it, customers is a master data. So there will be customers for a company, and typically it will not change as frequently. Similarly, for a retail platform, there will be a bunch of products called product catalog, and that also will not change that frequently. And then categories and departments. So out of these 6 tables, all these 4 tables, customers, products, categories, departments, which are not involved in regular transactions, we can consider them as master data tables. And whenever you place an order, these 2 tables will be impacted. Okay, for any retail platform, these are the main tables which will actually conduct the transactions. Okay, so orders will have one entry for each order with unique order ID, order date. So these are all attributes at order level. We have order ID, which is a unique number or primary key number when the order is placed, who places the order, which is order customer ID, and order status, which might change over time. It might start with new, then processing, then shipping, then completed, etc. So these are all attributes at each order level. And when you think about platforms like Amazon, Flipkart, or any other retail platform, you can place n number of items in each order, right? That's why we have a child table called order items. And these order items have parent foreign key relationship to orders. So here order ID is primary key, and for order items, order item ID is primary key. For each item, there is a unique ID, and then there is another field called order item order ID, okay, which stores corresponding order. So if there are 3 order items for an order, there will be 3 entries in order items. Order item ID will be different, but order item order ID will be same. Okay. So these 2 are transactional tables. Whenever there is an order placed or any changes in the order, most likely these 2 tables will be impacted. And these are called as transactional tables. Okay. So using this relational model, which is supporting a transactional application, we want to run analytics. Okay. And this is the source database. We will pull data from this source database, which is under MySQL, typically using Scoop or some other mechanism. Once the data is there in downstream systems, again, there will be a stage database, there will be EW database, there will be so many databases to process this data. One of the tools we can use is Spark. We can use Spark transformations and actions to apply whatever transformations we want. As long as there are tables associated with these things which are accessible through Spark, we can run queries like similar to SQL. Otherwise, we have to use Spark transformations and actions. Okay, so we'll be using this data set to do the next exercise. First, let us vaguely define a problem statement to explore few things. Okay, here in this case, let's say there is orders table and order items table, and there is the order date for each order. Okay. So using this order date, let's say we want to compute total revenue for each day. How much how much revenue the platform is generating on each day. So order date is available in orders, and order item subtotal, which drives the revenue, is actually in order items. So to get a total for each day from these 2 tables, we have to join these things. So now we will explore what are the APIs that are available, first to join these 2 tables, and then to actually aggregate. Okay. So again, I'm going to Spark programming guide. So any questions with respect to data model? Okay, so again, we are talking about transformations and actions. And in this case, our requirement is to join the orders and order items and then get the total revenue for each day. And also, if you go to the source database here, we'll not be connecting to the database. We'll be fetching data from the file system, files in HDFS, and we'll be doing these transformations. I'm connecting to database to show certain things. I'm connecting to, again, MySQL database by using username retail_dba and password ITversity. And then I am connecting to retail_db database. Okay. And then show tables. We have 6 tables, and we are talking about orders and order items. Okay, so there might be generally this will be a common question when people are debating between reporting from transactional based systems and data warehousing systems. People are typically tempted to join these two tables and get that report of how much revenue being generated every day. Okay, so the reason why data warehousing is important is I can run the join between these two tables and get the reports. There is no issue. I can just run select order date and then sum of y dot order item sub total st from order so join order items y on o dot order id equal to oi dot order item order id group by o dot order date. If order date have timestamp, we might have to trim off the timestamp and then get only the date. Otherwise, we can run this query, and it will definitely give the order item sub total, not sub underscore total. Let me copy paste these things. See here, we are for each date, they are not storing timestamp, so we can actually get it like this also. But we don't do it typically. Why? In our case, we have only 68,883 records in orders, means there are only 68,883 orders. And then 172,198 order items, means for each order there are approximately 3 order items. This is for our simulated retail data model. But if you think about companies like Walmart, Target, even Flipkart, Amazon, these are all retail companies. Or you can think about Big Bazaar. All these will have hundreds of thousands of orders or even millions of orders. And if you see, we are actually joining to get the revenue for each day. We are doing complete join between the two tables, right? And these joins are very expensive. Even though it returns very fast on this smaller data set, if you think from production perspective, these joins are very expensive. So even though functionally we can run these reports on source systems, we typically don't because it can impact the functionality of the source applications because of the overhead to run these queries. Hence, we will build a separate systems called data warehouses or analytic systems. We pull data from the source systems, apply the transformations, and also to get the reports faster. So even though if we copy this data to a data warehouse and we can actually copy the data and we can report directly on the relational model, something like this. Okay, we can maintain the same data model on the target system and we can run the queries there. Again, the caveat is, or the drawback is, when you actually run these queries on the fly, if there are millions of records and if we get reports between a department and then revenue for each department for each day, then the number of tables that needs to be joined, etc., will be very high, and your queries will take forever. Okay, for that reason, instead of applying transformations at the response time or request time, we will actually pre-process the data in typical data house implementations, we actually pre-process the data, and on source we will have normalized data model like this. On target we will have dimensional model, and in dimensional model you need to understand terms like facts, dimensions, etc. Okay, in that case we will reduce the number of tables needs to be joined, and our reports will be much faster because the data also will be pre-aggregated. Okay, for all those practical purposes, we need to come up with a ETL framework where we extract data from source databases where data is modeled like this, apply the transformations either using Informatica servers or Hadoop clusters. You can use any infrastructure to apply the transformations by applying certain rules, and then load into the target data model where your reports will be written faster. That's where ETL comes into picture, and Spark is one of the powerful ETL tool where it can scale easily, and then we can load into any lightweight reporting database and we can report off of it. Okay, so this is a very common question typically people get: why can't we run these reports on the source database itself? Here we don't have enough volume, so it will return fast. But in production, where we have real tables, these transactional tables are pretty heavy, and we should not be running these reports on the source databases directly. There are different designs where we will consider where the data needs to be transformed and how it should be transformed, when it should be transformed, and then we will report off of it. It all depends upon our project requirements. Okay. So now we want to get this data to Spark, and we want to process these things. There are multiple ways to get to the Spark. We can run scoop on these tables and get data into HDFS and then run Spark on top of it. Or we can also do Spark JDBC. We can connect JDBC. We can connect to the source databases using JDBC from Spark directly. We can fetch the data and we can process. So there are multiple ways to do that. The typical way is to use Scoop. In some cases, people use Spark also, Spark using JDBC. Okay, now let us get into the data, understand the data, and then try to explore different APIs of Spark to process the data. So if you run search star from orders, limit 10, we will get 10 records, and this is how data look like. We have order ID, which is unique ID, order customer ID, order status, and order date. And first we need to understand what are distinct order statuses in this table. This is all MySQL queries. Order status. Okay, so there are 9 different order statuses for this. Let's say we want to only consider complete and closed orders, okay, to get the revenue. We don't want to consider others. Okay, so let's focus on complete and closed. For that, we need to use certain transformation. You can guess it, which transformation we should use if we have to get only closed and complete orders from the data which is already in HDFS. Any guesses here? Which transformation we should use? Yes, Rauf, it's filter. Yeah. So we'll be using a filter to only get closed and completed orders. And then if you describe orders, there are 4 fields, and if we describe order items, there are 6 fields. So order item ID is the primary key, as I have explained. Order ID is the foreign key to orders. So if we have to join these 2 tables, we have to join between order item, order ID, and order ID. ID will give which product we are trying to purchase, which we are not interested in, and order item quantity is in each order item how many items are being ordered. For example, if you want to buy soaps, you might buy a dozen of soaps. So order item quantity will reflect the 12 in it. Order item subtotal is nothing but the total for that order item, which is computed by multiplying quantity and product price. Okay, so product price is per unit, subtotal is product price multiplied by quantity. So here in this case, we want to just get the get the revenue of the entire platform, retail platform on each day. So we have to join these two. From orders, we want order date, and from order items, we want order item subtotal. And to join these two, in orders, we need order ID, and in order items, we need order item order ID. Start with let us start with Spark programming. I'm opening another tab here. And connecting to the lab. Ideally, we should develop only using our laptop, using Eclipse or Spark setup on our laptop. In my case, because I'm using this Windows, I could not set up everything here. I just realized that there is a problem last night, and I tried to get everything up and running on this. I'm not yet done. Hence, I will be using the cluster itself, and directly I will be developing on the cluster. Okay, so here I need to get the password. And then I want to launch. So first, let us understand that we can read the data, which is under public retail underscore DB. Okay, so here we are not going to connect to the database. We will be using this data, which is already in HDFS. Orders can be retrieved from this one, this directory, and order items can be retrieved from this directory. So now I am launching Spark Shell. Okay, so here I'm creating, already SC is created, so we don't need to create SC or conf objects here. Spark context is already created with variable SC, so we can actually read orders saying by giving a name, and then I can read it using sc.text file. We have to give the path. It's in HDFS, and the cluster is already integrated in such a way that Spark can directly read from HDFS. So we don't need to give the HDFS URI as part of the path. We can directly give the path of the files, which is public orders, and hit enter. So first thing you need to do is validate that this location is correct. Okay, so one of the simplest way is to say orders first. Okay, it will fetch one record. First is an action which you can perform. If you go through the programming guide, you can see that. Okay, here if you go scroll down, there is an action called first, which is nothing but take of one. We can use that to preview the data, and here you can see that it is retrieving without any issues. And now we want to get only the data where orders are closed and filtered. So this is nothing but so if I say orders, it will give the data type. The data type is RDD, which is nothing but a collection, and each element is of type string because we are using sc.text file to read the text data. So each element is nothing but record. Okay, now we will create another RDD with the name filtered, and then we can say orders.filter. So filter, here we need to give the expression which returns either true or false. Okay, if the expression returns true, the incoming record will be considered. If the expression returns false, the incoming record will be discarded. So this filter will be applied for each element in the RDD, and if the condition is true, that element will be passed on to this new RDD. If it returns false, that element will be discarded. Okay, so here that's how orders filter will work, and we can say underscore dot split comma. So what it will give? So let us try to use the regular string and see how we can actually come up with the filter logic. Okay, so here I am creating string the same record. Okay, and then if I say string dot split, comma is the delimiter, so we have to apply split using that. What split is giving? Split is giving an array, and we can read each element in the array by saying by using subscript. Okay, and in Scala the subscripts are represented using circular brackets, not square brackets. If I say 0, it will give the first element. If I say 1, it will give the second element, something like that. Okay, like that you can actually read the last element by saying 3. So we need to fetch as part of the filter, we have to get the last element after applying the split function and see if it is either closed or complete. Okay, so if we go back to this, and if we actually do select distinct order status, we have to check for closed or complete. Okay, so here val orders let us name them as completed orders equal to orders dot filter. Here we have to give the the expression which will either return true or false. So split data is delimited by comma, and we have to fetch the third element. Okay, and then we have to say equals. It's similar to Java. In Java also we can use equals. Here also we can use equals. I will get to that question, Sunil. Just let me finish this. Right. And then or split equals Okay, so here I think I have to give the pipe, not or. One minute, let me get the syntax. Yeah, it should be like this only. Okay. Okay. Hmm. Somewhere syntax is not correct. Equals complete. Let me give a name to it. Probably that could be the issue. Okay, order. Yeah. So that is the so there are certain limitations when using underscore notation. That's why it failed. Okay, and better way of doing this is you can actually write multiple lines also. So what you can do, just copy till here, paste it. If you have to write it in multiple lines, you just have to start this with this braces, and then here we can actually say uh, val string equal to, we can apply this logic. We can just say this one up to here. So we are trying to get the last field into a string, and then we can say if string dot equals complete, or string dot equals first. Okay. Then we want to return uh, true, else false. Okay, and then we can close the brace and close the circular bracket, and then you can filter like this. And also there is a ternary operator you can use. In this case, I'm just using regular if else condition. You can also use the ternary operator. Okay. Now, if I say orders, so immediately you should validate whether it is working or not. So you can say count and see how much it is actually giving, 30,455. Orders.count is 68,883. So it is actually filtering some data. If you want to preview, you can also say orders completed, take of 10 for each println. At each and every step, you should run this to make sure that it is actually doing what it is supposed to do. If you delay it, later you will not be able to troubleshoot that easily. Especially when you are under pressure for the exam, it can become challenge. Okay, So is it clear so far how we can actually apply filter? You can try several filter options, whatever works in Java, most likely it works in Scala also. Only thing is, as part of the filter expression, it should either return true or false. That's the main thing. Okay, let me scroll up here. So this is main thing. Let me copy this to Sublime so that if I have to refer, I can refer easily. Okay. Now again, I have to struggle to with the font of the Sublime. I will do that. Just give me a minute. Okay, I think preferences. Preferences font. Okay, font. Okay, there here itself. Okay, that's good. So control plus equal. Okay, it is better. Okay, so this is how you can write your filter. Filter should always return true or false. Also, as a one-liner, you can write like this in a functional manner. Okay. So is it clear about filter? Now I will take some questions. So from Sunil, delimited should be given based on file in HDFS. No, delimiter should be given based on data in HDFS. Whatever format we are using while storing in HDFS, the same thing should be used to read. Okay, so again, it's an integration point between the data load module into the HDFS and data processing module like Spark. They both have to have they both have to have technical specification which are agreed upon by both the teams. Okay, in this case, we have to go to the data and understand how the data is stored in HDFS, and based on that, we have to split. In this case, as it is comma, we are using comma. If it is pipe, we have to use pipe. Is it clear, Sunil? Okay. So now we have filtered the data. Once we filter, again, if we run this take of 10 command, I'm running again. You can see 10 records only with complete and closed orders. So data is already filtered. And what is the variable which is having the filtered orders? It is orders completed. Okay, so this is the RDD, and you can see that each element is of type string. Okay, and here we haven't applied any transformation to convert this. We are just processing as a line, filtering out whatever is not required, and then we again got the filtered data, but of same data type string. Okay. Now out of these 4 fields, if we have to compute revenue by date, okay, which all fields we need? We need to join with order items also. You have to keep that also in mind. And here you have to tell me what all fields we have to fetch from this data so that we can join with order items and also to run the revenue. Any guesses here? Anyone who want to answer that? What all fields we need to get it from this orders table? And if you want to recollect what the field names, Here are the field names: order ID, order date, order customer ID, and order status. And what else, Ravindra? Order ID for join, and we need one more field because here we are talking about getting revenue by date. Yes. So we need to get order ID and order date. So how can we get now from this data set where we have filtered complete and closed orders? We want to get order ID and order date. How can we get it? Get those two fields. Which API we should use? Order status is not required, Ravindra, because we have already filtered out based on closed and completed orders. Okay, so we don't need to have this status unless we want to display later. In our case, we don't want to display. We just want to get the revenue for each day. Anil, split is not Spark API. Okay, so split is not correct answer. Split is a function to delimit the data and extract the information. Here we need to get two fields, and we have to use the Spark API for that. For each input record, we need to get one output record, and that output record should have only order ID and order date. So which Spark API should we use? I have already covered that. That's why I'm asking that question. You can go to Spark Programming Guide, go to transformations, and check the APIs that are available over there, and then guess which transformation we should use to get order ID and order date from from each of these records. Any guess? I will give 10 more seconds. 5 more seconds. Sumit is correct. Sumit actually give the logic also. We have to use the answer for my question is we need to use map transformation or map Spark API on top of RDD to actually extract order ID and order date. And here, when you extract order ID and order date, you can extract the way you want. Okay, it can be comma separated, it can be anything. But here we want to join downstream. So it has to satisfy the requirements of the join. Now I am going to the Spark Programming Guide again. Okay, and I will try to explain what are the requirements for the join. Okay, so here I am going to transformations again. And it's self-explanatory. We have two data sets, orders and order items, and we have to join those two. And there is a join transformation for it. Hence, we can use join to join the two data sets. Now you should read this and you should be able to understand how the data should look like. What it is saying, when called on datasets of type KV, what is this? Any guess? What is the term we can use here? Key value. There is another term, data structure within the Scala to talk about this, and it is called as tuple. Yes. So we require two data sets where there will be two elements in each tuple, and when we join, what it will generate? It will generate another tuple. First element will be the join key, and the second element will be the values from both the data sets. Okay, so if you interpret this, you are good to go with joins, and then we can do left outer join, right outer join, full outer join, etc. I will cover a little bit later what are they. Okay, here we are trying to do plain join, so it requires two data sets of which look like this. Both the data sets should be tuples. Okay, and from Spark it rec for record. Rec stands for record. And then we have to create a tuple, and hence I'm having opening bracket and closing bracket, and this bracket is for this one. Okay, so we have closed everything. I just want to make sure that everything is closed properly. So first I closed the brackets, and now rec dot split. Okay, and the delimiter is comma, and we want to get the first element as key, and then second element as value, which is order date, right? Okay. Now, so here we are trying to extract order ID and order date from the MySQL database. Order ID is of type int, so we know that in source database the data is stored as int. Okay, so now my question is, when we split this record and when we extract order ID like this, will it return integer or string? Any guess here? Will it return integer or string? It returns string. So we have to typecast. If you don't typecast, we will run into performance issues. So how to typecast? There is a function called toInt. So we have to apply toInt. Okay. For date, you can either process as string or date. It doesn't matter. I will be leaving it as string. Okay, and hit enter. Now you can see it has created an RDD, and there is a each element is of type integer and string. Okay, we can preview the data. Orders tuple take 10 for each println and hit enter. Okay, so we got the order ID and date. And this comma is not because it is string, it is because tuple, the key and the elements in the tuple are separated by comma. This is the one which will come from that each element is tuple. Okay, and also when we actually do, when we run this, it actually gives the data type of the RDD, I mean each element in the RDD, which is of type tuple. Using this information, we can confirm that this is actually a tuple of one element is of type integer and other element is of type string. Now, I'm actually going back to the database and going to order items. So here our requirement is to get revenue for each day. Okay, so from this data set, which two fields what all fields we should get, so that we can join with orders and do the aggregation later. Here we are talking from the join perspective only. So which two fields or which all fields we should get from order items? Order item order ID for join and order item subtotal. In this case, we already have order item subtotal, which is having the revenue for each order item. If that field is missing, we have to get quantity and product price. Using quantity and product price, we can always compute the subtotal. So in this case, as we already have subtotal, we can get that. And here, this one is the second field, and this one is fifth field. So we have to get these two, second and fifth. We have to remember that. And go here, and then val order items tuple. First, we need to read the data set, right? So let us read that order items equal to sc.text file public retail underscore db order items. Okay, you can say order items first to see it is actually reading the data properly, and also to get the count, you can say order items dot count. There are 172,198 records. Now order items tuple equal to order items dot map. Here also we need to use map function. Rec implies rec dot split, comma, because we need to get order item order ID, which is second field, which is 1, and then 2 int, and then we have to get order item subtotal. Rec dot split, comma, which is 1 2 3 4 5. So here we have to say 4. And what is the data type here? It is float. So we have to typecast to float, or probably to double, we will see. And then close it for the tuple, and close it for the map, and hit enter. Now you can see the key is of type int and value is of type float. We can also read the data, take off 100 for each integral, and you can see the data. Okay, so we have seen how to read data from orders and order items so that we can join. So we'll stop here. We are already 1 hour done. So if you have any questions, I will take it. So tomorrow we'll resume here, from here, where we will use this orders tuple and order items tuple, and we will perform the join, and then we will talk about aggregations. So far we have seen map, filter, flat map. I will cover map partitions little bit later. It is not that important at this time. And then we have seen reduce by key briefly, but we didn't get into too many details when we have written word count program, and we directly jumped on to join. So as part of the next tomorrow's class, we will primarily talk about joins, and we will also see how orders and order items can be joined, and also we'll see what is left order join, what is right order join, what is full order join, and then we will get on to the aggregation to get revenue for each day. Okay, any questions here? Okay, so guys, you can take a couple of minutes break. I will stop. I'm stopping recording this one, and I will close the YouTube live session, start it again, and I will resume this one. Okay, I will put you on mute, and then remind me if I forget to record. And those who are on YouTube live, thank you very much for joining the session. As I have been saying, if you want an environment to practice, please go to labs.itversity.com, and you can sign up to the lab. These are the plans. We have $14.95 for 31 days, $34.95 for 93 days, and $54.95 for 185 days. And you can practice whatever you are seeing. If you have any questions, whether you subscribe for the lab or not, you can always hop on to discuss.itversity.com and start raising the questions, and we'll be glad to help you. Okay. So that being said, thank you very much once again to join the session. If you like this content, please click on the like, and also please share with your friends. By just clicking on this, you can share it on YouTube, Facebook, Google Plus, LinkedIn, wherever it is, and then it will help me to get some traction among the crowd. That being said, thank you very much. Bye.